Hello, good morning, everybody. Our capstone project is called Where's Carrie, provided by Dispatch. We are Team Skynet. My name is Alexander Lamont, and these are my teammates, Brian Green, Nick Ishihara, and Edgar Sandoval. Our team worked closely alongside our peer mentors and co-founders of Dispatch, Stav Braun and Uriah Balk, and today we're excited to present to you what we've been working on during the span of the semester. But first, we wanted to share some background and the motivation behind our project. Dispatch is a startup company founded in June 2015, whose goal is to create a platform for local delivery. And this platform is powered by a fleet of autonomous vehicles that are designed for sidewalks and pedestrian spaces. Now, unlike its competitors such as Amazon's drone delivery services, Dispatch will be able to deliver packages to locations such as a local park, rather than a specific address. Now, with the rise of Dispatch came the need for the development of our capstone project.
All right, thank you, Alex. So, who here has used Amazon and purchased something? Can I get a show of hands? Great. So at one point in time, we would always go online to search for the tracking system for where your package is. So that's what our job is. Dispatch gave us the honor to do a real-time website to build to track their autonomous robot, also known as Carrie. They had the technology and the robot, but they lacked the tool to monitor the robot at one point in time. So what our deal was to create a website that would give customer information of past deliveries, packages, and its route, and also give a broader network to Dispatch to see where Carrie is making path to your destination. It also will track the speed and also the battery life of Carrie's current situation. So our goal was to make this real time from the last slide using Google's API to plot markers. One, a start marker, a destination marker, and a third marker, which is the purple marker, which is Carrie's exact location. This exact location moves in real time on our website, showing Carrie's specific latitude on Google's API. And I'm going to pass it on to Edgar for the tech stack.
Thanks, Nick. So as Nick was saying, we had a very interesting time trying to work with the real-time environment. Basically with real-time, you need a different set of tools to help you out. Basically with the amount of data that's coming in, you need something that can broker those messages, which is why we came up with a protocol and a specific tech stack for this. In general, we use something called the Lambda Stack, but it's more of a pseudo Lambda Stack because it does not consist of a persistent layer. After we came up with that protocol and that stack, we needed to do some research on website design. We found that event-driven programming on the website end was probably the best option for us, which is why we chose Node.js. After that, we needed to tie all the loose ends together and make a fully functioning website. If you go to the next slide, we'll get a picture of the tech stack. So every 5 milliseconds, Carrie is posting a snapshot of its status to the user. Like we said, we wanted to give a real-time update, basically so the user could track their package or track Carrie in real time. With that, we use tools like Kafka and RethinkDB because they can scale horizontally and they can read and write messages, like millions of messages per second. To connect the back end and the front end together, we use Socket.io and Node.js and Google Maps. And these are the tools that we use for our project. A lot of the time was spent on the web layer, and probably the equal amount of time was spent on our Kafka server. I'll give to Brian so he can speak about the demo.
So at the top, you can see that we have a green dot, red dot, and a purple dot. Currently, I believe it's showing the historic view. But when it goes back to the green, purple, and red dot, the green dot is the starting location, red dot would be the ending location, and purple dot is where Carrie currently is. You can see the stats on its speed, its current time, and battery life. It'll also show a set of photos that are flashing by. The actual deployment when Carrie is going live, that's 20 frames per second in form of a video. It's difficult to push a real video up, but 20 frames per second will do when you're sitting at home and you want to see where your package is. Currently, UPS and Amazon, FedEx, and all them don't offer that. So some of our challenges were tracking carry in real time. The biggest issue with that was if we pushed too many messages too fast, we lost carry. If we didn't push enough messages, we lost carry. If we pushed, just the right amount, we somehow lost carry. So we had to figure out where and why we were losing carry, how we were losing carry, and after spending the majority of the semester figuring that out, we finally got carry back. The next biggest issue was pushing data to the dashboard. If you pushed too much data at once, the ending location moved. If you didn't push enough, carry didn't move. So it was a really find the balance, find the perfect place for carry. And the last biggest issues were making the photos into objects. As you can see, everything else there was text. Even the GPS coordinates, that's coming through as text, and we're just taking that text and placing it as a GPS coordinate. The images aren't text. We had to figure out a way to get the images to transfer with the text, which took us about a month and a half just to figure out. And lastly, the largest issue was we only had limited computers working with Linux. We had 2 computers running Linux. One was fairly slow, the other one was on a different flavor, and it added a bit of confusion whenever we transferred the project between both computers. So our future work is we like to add package tracking. Currently you track a robot, a specific carrier. So if you order something, you're gonna get package ID. So in the future we'd like to be able to place your package ID in there instead of your robot and be able to track your package. And lastly, future generations of carry will have LiDAR, which is a way for robots to visually see the earth around them. We would like to be able to place that LiDAR, what carry literally sees, on that web page. So some people we'd like to acknowledge are Stav Braun and Uriah Balk from Dispatch. And we'd also like to thank Dr. Miguel Lara for helping us a little bit with the front end here and there, and Dr. Satya Narayanan for helping put together this entire capstone class. At this time, are there any questions?
I see great potential in addition to the robot. How small is the package? Can I put it on my dog?
So the question was how small is a package, or how large of a package could carry handle? Currently, carry can handle anything.
Your device.
Our device? The device is actually the data is being sent from carry within carry. There's multiple smaller devices. They have a current Intel box, about yay big, sending all of its current information to their server, which we pull our data from.
Does carry keep cooking hot and cold?
Not yet.
Could I use the location tracking system to intercept carry before it got to my house?
You could, however, carry does have a way to lock all packages within it until it's reached its destination. So even if you were to intercept carry, you would have to, wait for it to get to its destination before it would allow you to open it up.